what we're looking at here is May has this paperweight right here. It's the shape of a dome. And she can look through it, I guess, which is kind of cool. It's made out of glass. And she wants to protect it. Sometimes things that are made out of glass are fragile. So she wants to put it in a box where it fits snug. Why would you want it snug?
So it doesn't shake.
Yeah, because if it's glass and it shakes, it's going to break. Okay? So what we know is that it has a radius of 3, the hemisphere. What I want you to tell me is, what should the dimensions of the box be? What would the volume of the box be? And what is the best guess estimate of the volume of the paperweight? So the first thing is we need to get dimensions for our prism. Who would like to give me some dimensions and how they know that? Lily?
I think that the bottom, like side,
Yeah.
are 6.
Yeah, and how'd you get there?
Because it's the radius times 2.
Yeah, so the radius would go to the center, and then to get to the other side, we need 2 of those.
That's the
And then,
diameter.
Lily, what'd you get here?
Or I think that one's 6.
This one right here? So let's take a look.
I agree.
Did you notice this right here?
That's radius.
So what do you think the height is?
Probably 3.
3. Okay. Yeah, it's tricky. It's a 2-dimensional picture, which always makes getting to the 3rd dimension like tricky. Like, I don't know about you guys, but sometimes I look at it and I see different things even. So we've got a 6-inch by 6-inch by 3-inch.
I'm hard to tell if the hemisphere is.
So what's the volume then? 36 times 3?
108 centimeters cubed.
108 cubic centimeters.
Meredith.
Okay, what are some guesses for the hemisphere? Give me a guess, Ivy.
50.
50? Yeah.
75.
75? So some people are thinking like 2/3, something about half, a little more than half. I kind of cheated. I said, I'm not exactly sure what it is, even though I do know what it is. But I said it's like less than 108.
Well, I wish that's
Because I know it doesn't take up the whole thing. This isn't like the right answer. All your guesses are what you should be having down. But I think the big takeaway here is it has to be less than 108 because it doesn't fill the box completely, correct?
Yes.
correct.
So I would probably guess somewhere in like the low 50s. But
We got 48.5.
that's, yeah, they're all good guesses.
It's 2/3.
So if our new box is twice as large, there's a couple ways we can go about this. Just out of curiosity, who did something like 12 times 12 times 6? It's good if you did that. I'm into that.
Times 3.
Well, if it's twice as large, it'd be in all 3 directions. Okay? So what I chose to do, though, is remember when we changed one dimension by a factor, our answer changed by that factor? And when we had 2 dimensions that we changed by a factor, it changed by that factor squared? So 3 dimensions at a factor of 2. What I chose to do is 2 to the 3rd times that 108.
Makes sense.
2/3 of the cylinder.
It's 2 to the 3rd power.
So it's
Because we're just looking at the
Which
box,
is times 8.
which is times 8. 8 times more. So 864 cubic inches. Is it inches or centimeters? I can't remember. Centimeters. So you could just double all the side lengths, but remember the how many dimensions change thing? In this case, we're changing all 3 dimensions, which would be 2 to the 3rd power change of volume. So if we said triplet, that'd be 3 to the 3rd power, because we're changing in 3 different dimensions, each one. Okay, what's an estimate for the glass paperweight? What are you guys thinking?
I'd say 400.
Somewhere around 400?
It's 2/3 of
I'm going to say less than 864, though.
Really?
Yeah, I'm taking the safe way.
Oh,
Okay. And then what about the paperweight? Do you think the paperweight is also 8 times bigger?
Yes.
Yeah, because it also changed in 3 dimensions, right? The radius would have changed, which would have changed in all 3 dimensions of. So yes,
Yeah.
something like also changed
I'm guessing
all 3 dimensions, something like that.
I would say it's probably.
Okay, so it's 8 times.
576.
So just follow along this with me. If I had a cone in here too, which one would have a greater volume? The hemisphere or the cone?
The hemisphere, because it's
It'd have a great. So what does it also kind of looks like the hemisphere is like
Our hemisphere.
in between the cone and cylinder? Does that make sense?
I don't know which one's bigger.
So what I'm going to try to do to get close here is I'm going to find the volume of the cylinder and the volume of the cone because I can do that. And then I'm going to try to average them. And that's going to be close to the hemisphere, right? In between the two. So the volume of the cylinder first. I get pi r squared h. So that's like 125 pi.
Hemisphere.
So that'd be the volume of my whole cylinder, right? How do I get the volume of the cone quick from that? Divided by 3. So there's my cone. And what I'm saying is the hemisphere is something right in between there, it looks like, right?
Yeah.
Now, this isn't going to be perfect. This is an estimate. But the hemisphere is somewhere in between the cone and the outside of my cylinder. You guys can vibe with that? So what I'm going to choose to do, just to get close, is I'm going to find the average. Divide that by 2. So 125 pi, and I'm going to switch to 3.4 just for computation. 3.14. And I divide that by 2. I get an average about 261 and 2/3. So this would be like
Yeah, you say
about.
261. Or did you say 5?
So but this hemisphere has a different. I have side lengths of 5, right? So this is a different one. So let's look at the volume of the cylinder, not in terms of pi. 392.
I should get that. Yeah,
So the hemisphere again is somewhere more than half. Somewhere like you see, it's like a little more than half somewhere. Again, this is just an estimate. We can see that it's like part the way between the cone and the cylinder, and we can get a pretty good estimate there.
Yeah.
According to what we just saw, the cylinder, the cone, everything in the sphere all have the same radius. So let's take that knowledge and think about that. How many cones fit into a cylinder? 3. How many cones went into that cylinder? 1. So a sphere would hold how many of those cones then? 2 of the cones. So that's interesting. So let's go about that again. When we looked at that demonstration, we knew that 3 cones would have fit in the cylinder because we did that with the old cereal in class, right? But if 1 cone fit in and a sphere fit in perfect, that means the sphere would need to be equal to 2 of the cones. That's kind of cool, right?
Yes.
We know way more information now. Let's put it to work and get some volumes of these 3 figures then.
Yes.
We know that the sphere is just 2 cones. We know that a cone is just a third of a cylinder. We've got enough information to get some volumes here. Let's check this out. The first thing I always do when I get these is if it says the radius is 5, I go slap that on there, okay? Again, we know that the height is 10 because the diameter is 10. That's all we need. So we got 10 units. For a cylinder, the volume is pi r squared h, or 250 pi. We saw that today already, didn't we? Anyway, cubic units. So the volume of the cone is how much of that? 1/3, 1/3, right? 250 divided by 3. And then the sphere. Now, what did we say the relationship between the cone and sphere were? Ivy? Yeah, 2 cones would equal the sphere the way that it filled up that cylinder, right? So that'd be 500 pi. 250 thirds plus 250 thirds would be 500. Another way you could do it is we could have done the cylinder minus a cone, and that would have left us with the sphere as well, right? We took the cone out of the cylinder. I think it was easier to double the cone myself, though. Cool? Now, here's where I'm going to get so hyped. what we're going to do next is we're going to use the same idea where we found these volumes, and we're going to make the equation of a sphere. We were working with hemispheres. And I know I saw you guys just be like, just give me the equation, Mr. Mack. There's an equation. I want to know the equation. Well, I'm still not going to give you the equation, but you're going to get it yourself. You ready? You got to be ready, Troy. So check it. I will only do one thing to help you, one thing to get you started. This one, they said the radius is r, okay? I'm going to put that in there. Now it says, what is the height in terms of r? So how did we get the height last time? We looked at the sphere and we doubled the radius to get the diameter, right? So it's 2r, right? The diameter is still the height. It's two radii, right?
Yeah, that makes sense.
So there it is. What is the height of the cylinder? It's 2r. So I want you guys using our same equations we've been using for volume to give me the volume of the cylinder, cone, and sphere, please. So checking out this cylinder for volume. We know that volume equals pi r squared h, correct? We take our base, we multiply up. So pi r squared times 2r, our height is 2r. We follow? Now the next thing to tighten all that up is we're going to rewrite that as 2 pi r cubed. That is the volume of this cylinder. 2 pi r cubed. R squared times r is r times r times r. It's all multiplication, so you can rearrange it. Yeah, Ivy? Now, as we make the jump next to cone, I would suggest, what can I do with this to get the cone? I saw this on a lot of papers, by the way. I take my answer and do what? Divide by 3, because there's 3 cones in this cylinder, right? So for the cone, I'm going to do 2 pi r cubed over 3. Right? It's just whatever my cylinder was divided by 3. We good? Now here's where it's about to get crazy. That's for one cone. But a sphere, Meredith, is how many cones? 2 cones. So if I double my cones, what do I get?
2/3.
2/3 doubled though.
4/3.
4/3 pi r cubed. There's the equation for the volume of a sphere, everybody.
Bang!
We did it.
Wow.
Let's go. How awesome is that? I need you to do one more thing. We've done this with all of our shapes. When we know like everything but one thing, we can find the one thing. So just like with cones and with cylinders, if I gave you the volume, I asked for things like radius and height. Just like that, I'm giving you the volume of the sphere, and I want you to tell me the radius it would require. So let's take, I think 3 to 5 minutes, we can get her done on this. So I'm giving you the volume of this sphere. It's 288 pi. I want to know what the radius is that would make this true. So I don't think I saw this strategy in class today, but earlier today I saw a strategy of guess and check. Kids started throwing numbers in for R and see what would work. That could work. What I'm going to choose to do is solve the equation. And this is what I saw most people doing around the classroom. As I go to solve this equation, the first thing I'm going to do is just cross off. I'm just going to cross off pi. Because if there's a factor of pi on both sides, it's not changing the answer, right? So I know 288 equals 4/3 r cubed. Now here's the place I'm still seeing some issues universally, not just your class. Fraction use. If I want to get rid of 4/3, how do I get rid of it? Yeah, so I'm going to divide by 4/3, which is multiply by 3/4, right? We're going to multiply by the reciprocal. And what that's going to do is get rid of that and leave me with r cubed equals 72 times 3. I'll just do it. I got you. 216. So here's the little bit of a challenge. We need to figure a number times itself that equals 216. From here, I think guessing and checking is pretty valid. If you know how to use your calculator, you can take a cubed root. And in your calculator, most of the calculators, what you would do is you'd hit the number 3, which means cubed root, and then second, and you'd hit the button for exponents. It's the same button as the exponent button, but you hit second.
Wait, can you say that again?
Oh.
Of 216.
There it is.
So on your calculator, one more time, you guys know the exponent button on your calculator? It's like a little arrow that points up almost.
Oh yeah.
Like the to the button.
Oh, I did it.
If you hit second, that gives you the button that's behind that button, kind of. Okay. I'll show it to you later. But you could just guess and check, like 5 cubed is not enough. But it is 6. The radius has to be 6 to get a volume of 288 pi.
I got it right.
That's all we need, friends. Homework problems are on Canvas.